Hi all, it's me again, Aki from Bring Forth, and this is set 22, part 5. Could be part 4, let me check, part 5. And I'd like to talk about fusion energy and a lot of the misconceptions about fusion energy. A lot of people believe that fusion energy hasn't produced more energy than has been used in the starting of the reactor. This is untrue. The line of energy out was crossed in 2013, and I will now read a bit from Wikipedia. In March 2009, a high-energy laser system, the National Ignition Facility (NIF), located at Lawrence Livermore National Laboratory, became operational. The early 2000s saw the founding of a number of privately backed fusion companies pursuing innovative approaches with the stated goal of developing commercially viable fusion power plants. Secretive startup Tri-Alpha Energy, founded in 1998, began exploring a field-reversed configuration approach. In 2002, Canadian company Journal Fusion began proof-of-concept experiments based on a hybrid magneto-inertial approach called magnetized target fusion. These companies are funded by private investors including Jeff Bezos, General Fusion, and Paul Allen, Tri-Alpha Energy. Towards the end of the decade, UK-based fusion company Tokamak Energy started exploring spherical tokamak devices, and this is just the background. NIF, the French laser megajoule, and the planned European Union high-power laser energy research HYPER facility continued researching inertial laser confinement. In 2010, NIF researchers conducted a series of tuning shots to determine the optimal target design and laser parameters for high-energy ignition experiments with fusion fuel. Flying tests were performed on October 31st, 2010 and November 2nd, 2010. In early 2012, the NIF director Mike Dunny expected the laser system to generate fusion with net energy gain by the end of 2012. However, that did not happen until August of 2013. The facility reported that their next step involved improving the system to prevent Hohlraum from either breaking up a symmetry all too soon. So 2013 August is when we generated more energy in a first fusion test rather than requiring more energy. So that is a benchmark for fusion. Fusion power is most often viewed as the same kind of fusion that's in the sun. This is completely wrong. It's a slow kind of fusion. The sun's fusion is what has been called slow fusion. Even if we take the sun itself and compress it into something that we can actually fit in a tokamak laboratory, it will not generate more than 1,000th of what we can actually do if we manage to bring these fusion power plants online. Our fusion is different from the sun's fusion. It should be understood that they are not the same thing. Fusion generally takes seawater or some other form of hydrogen and does a hydrogen and deuterium fusion, and this is called heavy water. It's a form of nuclear energy or nuclear waste perhaps. And fusion generates nuclear waste as much as other forms of radiological like fission power, but the main thing is that fusion waste or fusion radioactive waste actually becomes radiologically safe to hold about 100 years after it's used in a reactor. So it doesn't take millions of years or even billions of years as some of this waste actually does. So fusion energy is much safer, but you have to understand that two main things when you hear a dialogue will basically give you all the information that you need. If they say it's the same kind of fusion as in the sun, they're wrong, they're lying, they don't understand the technology, or they're just basically fibbing it. And if they say that fusion energy hasn't produced more energy than is put into the system, they're also lying. Those are the two things you have to remember. We have, since 2013, actually had the more energy out than is put into the system, and it's actually much different from the sun's fusion. So that's basically all there is to it. There isn't much else to say. If we manage to get fusion power to work well, we will be able to generate nearly endless quantities of power. but this has been something of a pipe dream for 50 years, so it may not ever actually work. But our hope is that it will. So I will gladly answer questions about this topic because I'm something of an expert in it. I wouldn't call myself an expert enough to actually build a tokamak reactor, but a few people who are actually interested in this could actually build one. So anyway, that is all.